Hello everyone. Today's video is for the week of April 27th to May the 1st. This week we'll be talking about section 6.3 to 6.5. Mm, these three sections are on linear inequalities. Like I said, in linear inequalities is not in the current Math 9 curriculum, but we believe that you guys have the ability to do those. So I want to give you guys an idea what linear inequality is and um, just to have a basic knowledge of linear inequalities. Okay, um, so let's get started. Okay, so let's learn about the 5 inequality signs first. First of all, this one is not equal to. Um, so for example, 2 is not equal to 3. Okay, next. This one is less than. Example, 2 is less than 3. Okay, next one. Greater than. 5 is greater than 3. Less than or equal to. For example, 1 is less than or equal to 2, and 2 is less than or equal to 2. Greater than or equal to. 5 is greater or equal to 3, and 3 is also greater or equal to 3. Okay, and these 5 are the basic of linear inequality. You guys will need to get familiarized with these 5 signs first before you can do linear inequalities. Okay. Okay. Now let's learn how to graph linear inequalities on number line. Graph inequalities on number line. Okay. So when you guys have greater than or less than, your boundary points will be represented by an open circle. If you guys get greater than equal to or less than or equal to, then your boundary points will be closed circles. Okay, now let me give you guys a few examples. For example, x greater than 2. On your number line, you'll have, let's say, 0, -1, 1, and 2, and 3. So we know that x greater than 2 has a boundary point of 2. And because it's greater than, so the boundary point will be represented by a circle, open circle, like this. And it's greater than. Which side of 2 is more than 2? You'll be to the right, right? So you have an arrow pointing to the right. If you guys are not sure which side it is, just plug in a number into the equation. Let's say we want to do x is greater than 2. We don't know which side it is. So let's try, for example, 1. Is 1 greater than 2? No. So that means it wouldn't be the left side. We can try 3 as well. Is 3 greater than 2? Yes. So we'll go to the right side. Okay. Let's try one more. X is less than or equal to 10. So again, we'll have a number line. Let's do 9, 10, 11, etc. Okay, so this time our inequality sign is less than or equal to. So which circle do we use? We'll be using the closed circle. So draw a closed circle. And less than equal to, which side is it? Less than or equal to? You'll be to the left. If you're not sure, plug in a point and see if it works. So let's say we can do 9 less than or equal to 10. Is it correct? Yes, so that means it will go to the left. Okay, let's try 2 more examples. So if I have 3 less than or equal to x less than or equal to 5, then what does my number line look like? So let's do 4, 3, 5, 6, 2, 1, 2, 3, 4, 5, 6. This doesn't really matter. Okay. Now we notice that the first inequality symbol sign is less than or equal to. So that means the boundary point 3 will be a closed circle. Whenever it has an equal sign, it's a closed circle. So you shade the circle. And x is less than 5. Less than does not have an equal sign. So it means that your boundary point will be a open circle. Now notice that x is between 3 and 5. So we'll just use a line and connect those 2 points. We don't have arrows anymore because arrow just means it goes on forever. But in this example, x is in between the 2 numbers. So just use a line and connect those 2 points. Okay, now if a question says that people work at most 8 hours, then how do you represent this statement on a number line? We know that at most 8 hours means that you can work up to 8 hours. So 8 hours or less. Okay. So we know that this will be represented, the statement will be x is less than or equal to 8. At most 8 hours will include 8. So represented using a number line, 8, 9, 10, 7, 6. Okay, and our inequality sign is less than or equal to. So this circle will be a closed circle. And which way does it go if it's less than or equal to? You go to the left. If you're still not sure, plug in a value and check. So 7 is 7 less than or equal to 8. Yes, so that means 7 is in our solution region. Now we're moving into section 6.4, and we'll be trying to solve some basic linear inequalities. So let's do an example together. X plus 5 less than 3. Solving for linear inequalities is very, very similar to solving for linear equations. But there is one exception, and we'll talk about that exception in 6.5. Let's do this first. Okay, if you guys remember from solving for equations, when you have equations like x plus 5 equal to 3, you'll be isolating the x. You get rid of that 5 on the left side, right? And we'll do the same here for linear inequalities. So let's subtract 5 on both sides. If we do that, we get x is less than 3 minus 5, negative 2. Just like that. And that's our answer. And if the question asks you to represent it on a number line, you'll do negative 3, negative 2, negative 1. And negative 2, x less than negative 2 means it's an open circle. Less than, go to the left. Okay, let's do one more. If we have 2a less than or equal to a plus 4, same thing, we want to isolate the variables, so all the variables on one side and all the numbers on the other side. So I'm gonna remove this a here on the left side. So I'll do minus a on both sides, 0 pairs if you remember from the previous video. So 2a minus a will give you just a. A minus a cancels, and we have 4 left on the right side. So using a number line, 3, 4, 5, and a less than or equal to, so it'd be a closed circle. And which way does it go? Left. Okay. So these are basically it for 6.4, but there is or there are some special cases. Let me give you guys an example. If I have a linear inequality like this, 2x less than 2x plus 3, and we're trying to do it the same as linear equations, we'll be subtracting the 2x just to get rid of this term on the right, right? If we do that, then what we get on the left side will be 0 less than 2x minus 2x, 0, and plus 3 left. We'll get a inequality with no variables in it. If you get a answer that does not have a variable in it, that means this is a special case. So what you need to do here is ask yourself, is 0 less than 3 true? 0 is less than 3. So our answer is yes, 0 is less than 3. If your answer is yes, then that means x can be anything. It means that the statement is always true. Statement always holds, regardless what x is. So it doesn't matter what x is, your statement, your inequality is always true. X 0 is always less than 3. Does it matter what x is? No, because x is not even in the inequality. So this is our first special case. Let's do one more. If we have 2x greater than 2x plus 5, so same thing, we solve it first. Minus 2x on both sides, and so we get 0 greater than 5. Again, ask yourself, is 0 greater than 5 true? Is it? No. 0 is not greater than 5. So that means there is no solution. Or doesn't matter what x is, the statement is always false. Doesn't matter what x is, the statement is always false. Okay. All right. So if you guys see special cases, if your final statement after you simplified it is false, then that means there is no solution. Okay? If your final statement is true, then that means x can be anything. Okay, so that's it for special cases. Okay, now let's start on 6.5. So let's explore inequalities a little bit more. Let's say if I have 3 and 5, we know for sure that 3 is less than 5, correct? But if we multiply both sides by -1, what will happen? If we do that, then -1 times 3 will become -3. -5 times -1 becomes -5. Which one is bigger? If you're not sure, let's use a number line. So 0, 1, 2, 3, 4, oops, 5, -1, -2, -3, -4, -5. -3 is here. Maybe let me use red. -3 is here, -5 is here. Which one is greater? -3 is greater, right? Because -3 is closer to 0 on the negative side. So what do you guys notice? When you are multiplying by a negative number, what happens to the sign? If you compare this one and that one. The original sign is less than, and when you multiply by a negative number, it became greater. So here is the conclusion. And this is the only difference between solving for linear equations and linear inequalities. So when multiplying or dividing by a positive number, the sign stays the same. But if you want to multiply or divide by a negative number, what happens? The inequality sign will need to be changed or flipped. Okay, so when you are multiplying and dividing by a negative number, you need to flip the sign. Okay, okay. Now let's do a few examples together. Basic one first. Negative 8x less than negative 40. So we want to isolate x by getting rid of the negative 8 in front of it. And it's negative 8 times x. What's the opposite? It'll be divide. So divide both sides by negative 8. We get x on the left and 5 on the right. Now, because we are dividing by a negative number, what happens to the sign? Remember, it will be flipped. So instead of less than, it becomes greater than. That's example number 1. Example 2. Negative 4 over 7 is less than negative 8. Why? Now, you guys will notice that in this example, the variable, the y, is on the right side. And a lot of people don't really like the variables on the right side. They wanted to change it to the left side. So I want to switch the sides. Negative 8y and negative 4 over 7. But one thing you guys will need to remember is that whenever you switch the sides in a inequality, you need to switch the sign as well. So instead of, less than, negative 4 over 7 less than negative 8y, it becomes negative 8y greater than that. Okay, so when switch sides, the opening of your sign is always toward the same term. Now we just want to solve it by isolating the y, the variable. Divide by negative 8 on both sides. We get y. And because we're dividing by a negative number, so your sign will flip. And that is equal to, if you guys don't know how to divide fractions, we can do this aside here. Negative 4 over 7 divided by 8 is the same as multiplying by 1/8. So we have a common factor of 4, and that is equal to negative 1 over 14. Oh, and we're dividing by negative 8. Forgot to write the negative sign. So negative and negative cancel each other. And our final answer is 1 over 14. Just a few more examples. You guys can pause after I write down the inequalities and try it yourself on your own paper or wherever you write it, and check the answers after you finish. So 5 plus 3x is less than 11. Again, same as linear equations, we'll need to isolate the variable. So 3x is less than 6. Divide both sides by 3. We get x less than 2. Okay, next. 6 minus 2z is greater than or equal to 12. Get rid of the 6 first. We get negative 2z not equal to, it's greater than or equal to 6. Divide both sides by negative 2. We get z is, because we're dividing by a negative number, we need to flip the sign. So instead of greater than or equal to, becomes less than or equal to. Less than or equal to negative 3. All right, let's do 2 more. 2z minus 5 is greater than 6z minus 3. I'll get rid of the 5 first by adding 5 on both sides. So that'll be 2z greater than or not equal to, greater than 6z plus 2. And get rid of the 6z minus 6z minus 6z. Get 2 minus 6 is negative 4z greater than 2. Okay, now divide by negative 4 on both sides. We get z. Dividing by a negative number, switch the sign. And that's 1 over 2. Negative. Negative 1 over 2. All right, one last example. Negative 1 over 3 x plus 5 greater than negative 2 over 9 x minus 1. This time we have fractions, and we talked about this in the last video. We don't like to work with fractions, so we want to get rid of the denominators by multiplying by the LCD. And what is the LCD here? 9, right? So multiply by 9. Okay, so that will be negative 3 times x plus 5 greater than negative 2 times x minus 1. And distributive property, negative 3x minus 15 is greater than negative 2x plus 2. So we're going to add 15 on both sides. Negative 3x greater than negative 2x plus 17 plus 2x on both sides. We get negative x greater than 17. Okay, let me see if I can make this Can make a little more space. Yeah. Okay. And we can multiply by -1 on both sides. Negative x times -1 becomes just x. Positive 17 times -1 is -17. Now, because we multiplied by a negative, we need to switch the sign to the other side. All right, for your homework practice, please try 6.3 questions 2, 3, 5, 6, part ACE only for those 4 questions. 6.4, question 3, part C, I, and M, and 6.5, questions 3 and 4, left column only. You're welcome to do more, but I think this is enough practice for these 3 sections. Please try them and let me know if you have any questions. You can post your questions on Teams or email me. All right, that's it for this week's video, and that's it for chapter 6 as well. Bye, guys.